So in the last video, we talked about the special form of an equation, y equals mx plus b. This was what we called slope-intercept form because m is equal to the slope and b is equal to the y-intercept. What I want to do in this video is show you a couple of cases of some of the functions that look a little bit strange. The first example that we want to do here is the equation of the linear function y equals 4. Now, notice if we put this in y equals mx plus b, the y value is by itself, which is good news. The m is equal to the coefficient or value in front of the x, and the b is equal to the plane number. Now, up here, notice that there is no x at all in the equation, so that might look kind of strange. If you think, what could I put in front of the x to make it look this way? Remember, if you multiply anything by 0, that can become 0, and then 0 plus 4 is 4, and I can work this way. So if you ever come across a situation where there is no x at all, we can think of that as 0x. So when we go to identify our slope and our y-intercept, the slope would be 0, and our y-intercept would be 4. Once you think of it from this point of view, drawing the graph of this line is no different than anything else that we've done up to this point. We start by plotting the y-intercept. In this case, we're going to go up to b, the y-intercept of b equals 4. From this point, we're going to do rise over run, so we'll write our slope as a fraction, 0 over 1. 0 over 1, 0 is how far up or down we go, so we're going to go up or down 0. We're not going to go up or down at all, but we are going to run to the right 1, so we'll put one other point right next to it on a horizontal line. And then we can connect the dots, and what we have is we have a horizontal line that goes through the point that goes through y equals 4. Notice x can be anything, but y has to be equal to 4, so we get that really great horizontal line. And if you remember when we were talking about different types of slopes, we had slopes that were increasing where your slopes were positive. We had lines that were decreasing because we had slopes that were negative, and then we had horizontal lines when our slope was equal to 0, and that's exactly what we see happening here. Now, the last type of line that we talked about was a vertical line, and in that case, we said that vertical lines had undefined slopes. Well, what does that mean, and how can we kind of come up with that? Well, this is an example of the equation of a vertical line. Notice that there's no y in this equation, and that really is a problem for us because our idea of slope-intercept form completely revolves around the fact that the y is by itself. So we have an input of x with an output of y. Here, what we have is we have a completely undefined function. We have the input defined, x has to be -2, but there is no output defined at all. So there's a lot of confusion and a lot of uncertainty. And what that ends up being for us in terms of an equation is, like in this case, x is equal to -2 is this spot right here. The y value is undefined, so it can be anything, and we end up with the graph of a vertical line that goes through the point x equals -2 and passes through the axis that way. So again, remember that vertical lines are not functions, and the other problem with how we can notice that is that we can't get the y alone because there is no y. Can't get y alone because there is no y. And since there's no output defined, this is an undefined function. So horizontal lines happen. The equations will always look like this. Y equals a number with no x value. Vertical lines always happen when you can't get the y alone because there's no y even in the problem at all to look at. Hope that helps when you see those come up.